probability is always written as a fraction or a decimal. With regard to my six-sided spinner here, I'm going to look at the probabilities of landing on the different colour options. Because I have a six-sided spinner, my probability is always going to be out of 6. There are 6 chances when I spin the spinner. If I spin an orange colour, because there's only 1, I would have a probability of a 1 in 6 chance of orange coming up. With green, I have 1, 2, 3 green segments, so my probability of a green is 3 chances out of 6. That leaves me with blue. I have 2 blues, so my probability of blue coming up when I spin my spinner is 2 out of 6. I can combine probabilities. If I asked for the probability of spinning my spinner and an orange or a green coming up, I'd combine my colours. I have 3 green, 1 orange, so that's 4 possible colours out of a total of 6. My probability of an orange or a green is 4 out of 6. Here my probabilities are written as decimals, and you can see I have 1 missing. To calculate the probability of my spinner this time landing on green, I need to remember that probability is always out of a total of 1. If I add the probabilities that I have already, 0.15, 0.3, 0.2 and 0.1, they would make a total of 0.75. So the probability of landing on green has got to be the difference between 1, the total probabilities, and 0.75, which I can find by doing a takeaway sum. 1 take away 0.75 leaves me with 0.25. Therefore, all of these colours will equal the total probability of 1. Therefore, green has a probability of 0.25 of coming up when I spin. If I'm told there are 12 tickets in a draw and one of them is mine, and I wanted to work out the probability of my ticket winning the draw, I would have a 1 out of 12 chance. Here I have 2 boxes with different coloured counters. I'm going to pull a counter out of each box, and I want to be able to list the different combinations that could be pulled at any one pull. I'm going to do this systematically. I'm going to pull a pink out of the first box. With that pink, I could pull any one of those other counters in the second box. I'm going to pull a blue out. Still remaining on pink, I'm not going to pull a blue, but a red. There I have 2 possible outcomes. I have 1 more possible outcome if I pull a pink out of the first box, and that's to pull an orange out of the second box. So there, with my pink counter, I have 3 different possibilities of outcomes. I'm going to do this for each counter in total. Green next. There I have 3 different possibilities if I pull a green out of the first box. And then for my last one, I'm going to pull a yellow out of the first box. So now I have listed all 9 different options for pulling the different coins out of those boxes. If I were now asked for the probability of pulling a green and a red counter out, I could look down my list and see how many times green and red come up. That's just once. I have a total combination of 9, so my probability of pulling out a green followed by a red counter is 1 out of 9, 1/9. If I were asked for any combination that included a yellow counter, I could look at my list. I see that I've got 3 options with yellow counters, so the probability of that occurring is 3 out of 9. Very often with these kinds of questions, you're also asked for a colour that isn't in the box. For example, what's the probability of pulling a black counter out of either box? Because I have no black counters, the probability is 0. Here I have a probability line. I've got 3 counters in my box, and I'm asked for the probability of pulling 1 counter out of the box, that is blue. If I'm going to tackle this question and put my answer on the probability line, I first need to work out the probability as a fraction. What is the probability of my pulling a blue counter out of the box? My probability is out of the total number of counters in the box, that's 3, and the probability of it being a blue is 1 because I have 1 blue counter. The trouble with then going to put this fraction on my probability line is my probability line is only split into 2 and I need to mark it up as a third. So what I'm going to do to make that happen is I'm going to re-split my probability line. I'm going to split it into 3 equal pieces. So I want my line to be split there, and there. So I have 0, 1/3, 2/3, and my whole 1. I've already worked out that the probability of my blue counter is 1/3, so I will mark my probability line just here. Blue.